Kennedy's theory, critical velocity is equal to 0.55 into m into d to the power 0.64, where m depends on the type of soil, and it's called the critical velocity ratio, and d is the depth of flow. And design steps according to Kennedy's theory is, if Q and M are given, then assume D and find out VCR. And certain guidelines are given for the first trial depth assumption. If Q is between 0 to 20, then trial depth is 1 meter. If it's 20 to 40 meters per second, then it's 2 meter. If it's 40 to 80, then 2.5 meter. 80 to 100, 3 meter. Greater than 100, 3.5 meter. And when you have got the critical velocity, then according to your Q, then find the area of cross section by dividing Q by critical velocity. And assume the channel to be trapezoidal with side slope as 0.5 is to 1. 0.5 horizontal is to 1 vertical. Then you will get area is equal to BD plus D square by 2, and perimeter, weighted perimeter is equal to B plus root 5D. Moving on, step 4 is find B from, you have already gotten area from step 3, right? Now area, and you have D from step 1, so find the base width B from A is equal to BD plus D square by 2. And once you have B and D, then you can find P by P is equal to B plus D root 5. Then find the hydraulic radius, that is R is equal to A by P. Then find the actual mean velocity by Chezy's or Cutter's equation, as follows: V is equal to C root RS, and C, where C is the rugosity coefficient or the roughness coefficient, and C is not the rugosity coefficient. N is the Manning's N, or N is also called the Cutter's rugosity coefficient. Formula for C is equal to 1 by N plus 23 plus 0.00155 by S divided by 1 plus N by root R multiplied by 23 plus 0.00155 by S. If V critical is equal to this actual mean velocity, then design is adopted. If V critical is greater than actual V, then we need to decrease the V and decrease the D, that is decrease the critical velocity. So formula for critical velocity is 0.55 m d raised to the power 6.64. If you decrease D, then VCR will decrease. So naturally, if we assumed a D for which critical velocity is coming greater than the actual mean velocity, then we need to decrease D to increase VCR, and vice versa. That is, if we see our VCR is less than the mean velocity V, then we need to increase D. Okay. Moving on, Lacey's theory. There is nothing special about it, just many formulas. Right. So three basic Lacey's equations are, first one, velocity is equal to whole under root 2 by 5 FR. Second one is AF square is equal to 140 V raised to the power 5. Third equation is V is equal to 10.8 R to the power 2 by 3 into root S. These are the three equations. I repeat, V is equal to whole under root 2 by 5 FR. AF square is equal to 140 V to the power 5, and V is equal to 10.8 R to the power 2 by 3 root S. And how do you find F? That is Lacey's silt factor. It is found out by using F is equal to 1.76 under root D, where D is the dia of silt in mm. All the other variables are in SI unit except for this D, that is in mm. So F is equal to 1.76 under root D in mm. Other equations are 4 other equations we've got, and these are V is equal to Q F square by 140 whole raised to the power 1 by 6. P is equal to 4.75 root Q. S is equal to F raised to the power 5 by 3 divided by 3340 Q raised to the power 1 by 6. And R is equal to 0.47 Q by F raised to the power 1 by 3. I repeat all the 4 formulas. Then they are V is equal to Q F square by 140 raised to the power 1 by 6. P is equal to 4.75 under root Q. S is equal to F raised to the power 5 by 3 divided by 3340 into Q raised to the power 1 by 6. R is equal to 0.47 into Q by F raised to the power 1 by 3. Yep, that's it. And further, we have some design steps, like design steps for Lacey's theory. First, find you will be given Q and F, and step 1 is finding the flow velocity, that is V is equal to, recall, have you recalled it here? Okay, it is V is equal to Q F square by 140 raised to the power 1 by 6. After finding V, you can find A by A is equal to Q by V. Then we move on to find parameter, vector parameter, that is P is equal to 4.75 under root Q. Then assume cross section to be trapezoidal and side slopes to be same as the previous theory, that is 0.5 h is to 1 vertical. And the same formulas for area and vertical perimeter, that are A is equal to BD plus D square by 2 and P is equal to B plus root 5D. Using these two, we find B and D. Then finally we find the bed slope, that is S is equal to F raised to the power 5 by 3 divided by 3340 Q raised to the power 1 by 6. And that's it for these two theories. Play on repeat.